Okay, like I said, I'm just going to make a short video on how to find the correlation coefficient in the line of best fit. And I will say that this is one of those situations in statistics, especially in this freshman level course, where the calculations just become a little bit cumbersome and difficult to do by hand, and this is one of those places where I would say you definitely need to use your technology. If you had a program like StatCrunch or something like that, SPSS, or if you have a graphing calculator, we can do this on our graphing calculator, so that helps a lot. Alright, so what are we going to do? I'm going to kind of run you through, and over here I'll kind of do the math, and over here I'll talk about the calculator so that you can see it. I'm not huge on memorizing calculator steps, and in fact, I don't normally ask a ton of questions about this, being able to punch through the buttons on the calculator. There may be one or two on a test, but in general, I'm more of a conceptual person on this stuff, but I do want to show you, and if you have any problems with making your calculator do these things, or if it just doesn't look the same. There are different versions of software on different calculators. I'm going to use TI, but even in TI products, there are different versions. So, so here we go. What's happening? Okay, before we can try to find a correlation coefficient in a line of best fit, we need data points, right? Okay, so let's say we have a set of data. I don't know how we got it. Maybe it's, number of hours slept, or maybe it's measurements we took on, I don't know, weights of tomatoes. Maybe it's something else. But we have a data set. However we found it, we're going to then work with it. Now, the interesting thing is that usually, even if you're used to using a graphing calculator, you're not necessarily as used to doing the statistical stuff on the calculator. So I'm going to show you how that's going to work. So first of all, let me give you a set of data. And we're just going to say whatever the input was, or the independent variable, we're going to call it X. And whatever the output is, we're going to call it Y. So it's going to look a little bit like your algebra classes you may have taken before. So let's say if X is -4, we get an output of -16. If X is -2, we get an output of -7. If X is 0, we get an output of 4. If X is 1, we get an output of 10. And if X is 3, we get an output of 18. And for these kinds of questions, you would be given the data set. You would not have to find it or anything like that. So the first thing is knowing how to put data points into a calculator. So like I said, a lot of people might know how to use a graphing calculator and use y equals, but that just shows you a regular graph. Like I can graph 5x plus 4, which happens to be the equation that we're after here, okay? And I can see, there it goes, okay? So most people can probably do something like that on their graphing calculator. What they can't normally do is make dots come up. So we want to graph these data points and make it into a scatter plot. So number one, we want to enter our data to show a scatter plot, because we got to have the scatter plot before we can decide what it needs to look like, right? So I'm going to delete that. All right, so here's how we go. First thing you're going to do is you're going to locate your statistics button. I'm going to stick it right here. Hopefully we can see it. On a TI, 83, 84, that kind of stuff, you have these up, down, side to side buttons, and the stat button, statistics, zoom just a tiny bit. The stat button is right there beside it on the left, okay? So we're going to hit stat, okay? And you see this table, this list of things comes up. So I have three options up here at the top. Edit, and if I arrow over to the right, calculate, and I get a new list that comes up. And if I arrow over to the right, tests, and I get a new list that comes up. So we're going to start with edit, okay? And there's a ton more stuff that's available in this calculator than that this calculator can do just with statistic stuff. And again, if you're interested in some of that, just let me know and we can talk about it. But I'm just going to show you specifically what's needed for our linear regression here that we're going to do, finding our R values and finding our line of best fit. So we're going to use edit. So it's the first one in my list. I can either hit enter, oops, you can't see that, hit enter down here at the bottom, or if you see the numbered list, it's number 1 is edit, then you can hit the number 1 and it'll pull up edit. Now what happens here is you have all these lists. This is list number 1, this is list number 2, list number 3, list number 4, and so on. For our purposes, what we're going to do is we're going to put all of our data points into list 1 and list 2. And it kind of makes sense that list 1 will represent all my x values, right? Because that comes first. So I'm going to arrow over. I want you to be a little bit careful because if you go arrow up and you see how it highlights the L1 there, list 1, and it tells you what's in list 1, be very, 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 very careful. Do not hit delete. Okay, I've had students do that by accident. If you delete, this entire column will go away, and we don't want that. Okay, so if I want to clear out what's in there, I'll hit the clear button right here below the arrows, and see what happened here. L1 had all those data points in it, but now there's nothing. To make that for sure what I want to do, I need to hit enter, which again is way down here at the bottom, but I'm not going to keep it on the screen. So look, list 1 just cleared out. Cleared out. I didn't delete it, so be very careful, because if you delete your list, it's very difficult to get it back in. It's a process. It's not difficult, but it's a process. Okay. If you don't want to clear your list, then you can just type over them. So I'm going to enter my x values here. -4, I'm in the for L1, list 1. -2, the negative button is down here at the bottom of your number keys. -2, 0, oh, not plus, 0, 1, and 3. Okay. And then my y values are here on this second list, L2, but I don't want to start with 20, which is what's up there, so I'm going to just write over those. Okay. For the -4, it was -16. You have to be careful as you do this and make sure everything lines up. 4, 10, and 18. If for some reason, for instance, if I didn't put in this last data point, then eventually as I try to tell it to do stuff, it's going to tell me there's a mismatch, okay? So that means things just aren't lining up right. So if for every x value you put in, you need to put in also a y value. So I have 5 data points there, and that's what I have. Okay, cool enough, right? Okay, so in order to get out of here, I always hit second and then the mode. Remember that second highlights whatever's in that color. If you have a yellow button, it's the yellow stuff. Mine is blue, so the blue there is quit. So I'm going to hit second mode, and that quits me out of there. All right, I hit it twice. Okay, so enter your data to show a scatter plot. The first thing you need to do is stat and edit. And enter all your data points, okay? That's what we just did. Okay, the second thing we need to do is we need to stat plot. Okay, the plot part is what's going to show me my scatter plot. Okay, so if you look right here on top of your y equals, you see stat plot. Now again, that's blue for me, so I need to hit the blue second key before I get there. So second and the y equals, and see it's got that right there, stat plot. My stat plot number 1, which is the one we normally use, is already turned on, but I'm going to enter into it anyway so we can see what it looks like. If yours isn't turned on, then I'm going to arrow over to the off and hit enter. And now you see it says it's off. Okay. So my stat plot 1, I've got it turned off. Now, there's stuff in here you can do, and it always interests people. We're going to keep it on this scatter plot, and I'm going to go ahead and turn it on. So I'm just going to, it hovers over the on button, and then I hit enter, okay? That turns it on. And whenever the on is highlighted dark, that means it's on. And then the stuff that's highlighted here, we currently have it on a scatter plot. If you don't, you see in there as you look at it, let me zoom even more. Sorry. All right. As you look at it, you see right here, it looks like little dots, right? There's other stuff here, like there's a line graph, there's a histogram. This is kind of like a box and whiskers. This is definitely a box and whiskers. And this is a step model, okay, step graph. So we want to keep it on the scatter plot because that's what we're after. But I just want you to know that there's different options here that you could do. My X list, that's where my X values are stored. Well, we put them in L1. My Y list, that's where my Y values are stored. I put them in L2. I like either to use this box here, because it lets me see my values easily, or the plus sign. So to change that, you can just arrow over and then hit enter. You should avoid these two little bitty ones down here, okay, because those are really hard to see on your graph. But I like the box normally, so I'm going to keep mine the box. And then mine is a color calculator that I'm using right now, so it's blue. I can change that color if I want to, but most people can't. So that's what we're going to do. I'm going to second quit. By the way, see that my plot 1 is on. It's highlighted. Get out of there. And then I just want to graph it. And you see up here at the top right, there's the graphing button, right? So hit the graph. And I see some data points. For instance, one of my data points was 0,4, right? And I can see that point right there, 0,4. And one of my points was 110, and I can see it right there. But I only see 3 data points. I see these 3 right here in the middle, right? I want to see all 5, okay? So there's a couple of ways I can do that. Let me zoom back out so we can see a little more of the calculator here. Sorry about that. Ooh, too far. Sorry. I know. That's so irritating on the video when it happens like that. Okay. So now we graphed. Graph and adjust your window if needed. Okay, so that's what I'm going to do. I've graphed it. I see my plots, but my points here, my scatter plot starting, but I don't see all 5. So I want to see all 5. Now you can adjust it, and I generally would change my window to fit what's going on here. For instance, the problem is that the window, I'm hitting that button right there, window, it only goes to the x min -2, x max 10, or -10 and 10. That's okay on the x. But y min -10, I need a bigger y min, right? That's the minimum value for my y variable. And the max on the y is an 18. So I'm going to change both of those to -20 and +20, because that'll help me see what's going on in here, okay? So I like to manually adjust my window a lot of the time, but I'll show you a cheat in just a second, okay? So -16 will be in this area, and +18 will be too. So whenever I plot it again, there it is. I see all 5. And look, I see this is a pretty good line, right? It looks very linear to me. Okay, so while I'm in here, once I've got my window adjusted, I'm going to decide what the graph looks like. Okay, and this one's a line. But remember, we said we could have quadratics, parabolas, exponentials, etc., etc. So there's logarithmic regression and all kinds of stuff. And it all works the same on your calculator. So I'm going to decide what that is. This very much looks like a line to me, so I'm going to do linear regression, okay? So we'll do that in a second. I'll show you the steps for that. Okay. If you don't want to manually adjust your window, this button to the right of the window says zoom. I'm going to hit that. And if you look in here, there's zoom in, zoom out, zoom square, zoom standard. Zoom standard is the one the view that we normally would see. It's -10 to 10 on both the X and the Y. But I don't want a zoom standard because that didn't show me all my values. So the one that students cheat with in this class, and I call it a cheat, it's not, it's just really fast. And the reason I feel like it's a bit of a cheat is because if you don't understand what's going on, if you don't understand that I needed to go down below -16 and above +18 in order to expand that window, then the calculator is just doing the work for you here, right? So I'd like for you to understand that. And so, like on a test, there might be a window question where I say, what kind of window might you use, or something like that. Like it's a reasoning question. So the cheat that they use is this 9, zoom stat. And again, you can arrow down to 9 and hit enter, or you could just push the 9 button, whichever you want. So there you go. Now notice that this doesn't quite look the way mine did a second ago when I adjusted that window. I adjusted it, it was more vertical, right? It still looks like a line, but what's happened here is that they have kind of crunched it together here, and it's more spread out that way. So mine here, or I mean not more spread out, it's more zoomed in. So mine here was all the way out to +10 on the Y and -10 on the Y, and they don't look like they're doing that because they're only going down to -4 on the X value. Sorry, did I say Y? On the X value, they're only going to -4. Mine went all the way to -10 and +10. They're only going to +3 on the X value because those are the data points, right? But mine went all the way to 10. So adjusting that scale, we've mentioned this before, sometimes people use their scale to misrepresent some data. So watch out for that because we don't want to misrepresent our data, but the point here is, what does the graph look like? It still looks like a line, okay? So we're good here. All right, so what's happening? We've got that, okay. Okay, you want to see what it looks like. The trend of the data to decide the type of regression. That's what's happening. To use the type of regression we want to use. Okay, so that's what's happening here. Okay, all right, let's keep going a little bit. Now what? We think we want linear regression, right? So how are we going to do that? We need to find, so we need to find statistics regression table. Options, let's say options. Okay, but first, I almost forgot. Be sure your diagnostics are on. Diagnostics are on. Turned on. So we can find R, the regression correlation coefficient, right? Okay, so let's do that real quickly. Here I am. I was in the graph. I hit the clear button so I could go back to my home screen. Okay, this is my main home screen. I want to make sure that the diagnostics are on. So this is my number 2 over here. Okay, so what you're going to do is you're going to turn on diagnostics by finding it in the catalog. Now here's the thing, as long as you don't delete your memory, clear your memory on your calculator, once you turn your diagnostics on, they should stay on. Okay, so you only have to theoretically do this once, unless somebody clears out all the memory. So we want to find it in the catalog. Well, where's the catalog button? If you don't know, find your number keys, find the 0, and look right above that. In mine it's blue, yours might be yellow, but remember that if it's that color, you use that color button, right? So up here I've got a blue second key that matches the blue for the catalog. So it's going to be, for me, 2nd and 0. Okay. Catalog. Okay. So then I see, oh, it's alphabetical, absolute value, and angle, ANOVA, different things like that. So the nice thing is that your calculator should have already turned on, because we're in this alphabetical list, should have turned on the alphabet keys. So as I look here, if not, you can hit the alpha button, which for me is green, but it's right underneath your second key. But for me, mine's already turned on, so I'm looking for A, B, C, D. See those green little letters up there? Those match the green button, right? So I want D for diagnostics. So it's going to be this X to the -1 button, D. When I hit that, look, diagnostic or D's come up, and now I'm looking for diagnostics. So I'm just going to arrow down until I find diagnostics. Some calculators, depending on the software that's in them, they might just say diagnostics. Now mine says diagnostics off and diagnostics on. Clearly I want them on, so I'm going to come down here. But if yours just says diagnostics, then just hit the enter button, and bring up the diagnostic screen, and then make sure it turns on. Okay, so I'm going to hit diagnostics on, I'm going to hit enter. And notice it doesn't do anything, it just puts this in the home screen. So make it do something. You're not done until it says done or something to that effect. So I'm going to hit enter again. Okay, and now my diagnostics on, and the calculator's kind of saying, do you really want to do that? And I say yes, enter. And when I say I really want to do it, now I've got it. Okay, so now my diagnostics are on. Diagnostics. Okay, so for me, I was looking for D and turned on. Okay. And again, I'm not going to have to do this again. I just have to turn them on once. And now that they're on, yay. Okay. Now for the statistics regressions options. Okay. Now, unfortunately for us, we've already seen this screen. Okay, the statistics regression options. Okay, we want to go back to find the regression you want. Under the stat key. Okay, that's what's happening. That's what we're going to do. So we got to come back over here, and I need to find that stat key again. You'll get used to using it. Again, here's my arrows, and it's just to the left, stat. See it? All right, stat. I push it. We already used edit to enter our data, so now we want to find a linear regression or calculate that. So I don't want the edit column, right? I don't want this column. Instead, I want the calculate column. So I'm going to arrow to the right. The calculate column comes up. And we're going to use the linear regression that comes up first, AX plus B. The reason is because we want it to be linear, like a line, and we're used to seeing y equals mx plus b, right? Notice that there's another linear regression down here at the bottom, but notice it's a plus bx, so they've moved things around. We don't want that one because that's not the standard. We want number 4, okay? So I'm going to hit 4, okay? Again, depending on your software, you may not get this screen, okay? If you don't get this screen, then it probably just came up and said linear regression on your home screen. And if that's the case, just hit enter again, and it should do the calculation for you, okay? This is a newer calculator. This is not my personal calculator. So it brings up this template already filled in, so to speak. So as I look at it, it says, hey, where's your X values put? Well, we put those in L1, right? Where are your Y values put? Well, we put those in L2, right? Frequency list, don't worry about that, and don't worry about storing your regression equation. If you're really on top of things, I can show you how to do those things, but these don't really matter to us because we're going to write down our equation. So don't worry about storing the equation or anything like that. The one we want is this calculate down here at the bottom. If things were changed, if it wasn't in L1 and L2, I can change that, but I am. So I'm going to come down here. It's flashing on top of calculate, but it won't do it until I hit enter. So I tell it to hit enter. So here we go. The third one is find regression. okay, which is stat and calculate. And then for us, it's linear regression, AX plus B, which is number 4. On most TIs, 83 or 84s and 85s, 83s and 84s, sorry, it's number 4. And then we want to tell it to enter / calculate. Okay, so that's what we want to do there, and I'm going to hit enter, boom, and here it goes. It says, hey, here's your linear regression, and it gives me an equation. So now you just write the equation using the numbers given, and you'll be done. Okay, find your R as well. Okay, because we want both of those. Okay, so that's how we're going to do it on the calculator. Now, as I look at this thing, look, it tells me y equals ax plus b. That's the format of the equation. Okay, y equals ax plus b. But then it tells me, hey, your a is, what is that? Like 4.99. Well, that's really close to 5, right? Okay, so probably we could round, but we're not going to round just yet. My B is 3.79. 9. And actually, that would definitely round 795, right? So that would round the 9 up, so that would be 3.8. And 3.8 would round up as well. Okay, and here's the diagnostics part that we want. If you don't get this R squared in the R, it's because your diagnostics aren't on. So go back and turn your diagnostics on, and then you should get the R squared in the R, or at least the R, depending on your software. So here's the stuff that we really, really, really want. So my R is 0.998, and my R squared is 0.996. Okay, so I flipped them so I could have R first. Now remember that your R is your correlation coefficient, right? This guy's the one I want. But we mentioned just briefly, R squared is your variance, right? So this tells me how much of the variation in my data is allowed for using, because of the input value that I used, the input variable. Okay, so remember, these are supposed to be like probabilities almost. They're between -1, 0, +1, and this is 0.998, which is really, really, really close to 1. Okay, remember, you can read these if you want to, like percentages. So this is 99.8, this is 99.6. Both of those percents, right? Okay, if you want to think about it that way. So what this tells me is that my line of best fit that I'm about to write the equation for is really good. Okay, it's really going to hit most of my data points in this thing. So, and that's what we want. So let's look. What would the equation be? It's y equals my A here. I'm not going to write that. I'm going to write this guy, right? 4.99. Except that I'm thinking, I'm going to round that to 5, because probably 5 is close enough. Now, if it says in your directions, you know, keep 1 decimal place or something like that, then fine. But probably that's what we've got, is a 5. Okay, here's the x plus, and then the b value is, we're going to use this. We're not going to write b as a variable. We're going to figure out what the value is. That's the whole point of this exercise. So again, I could say 3.8, but just to make life easier, I'm going to say round that up and make it into a 4, because it's above 3.5. Okay, so I think this is my linear equation, and that's just a lot cleaner than saying 4.99x plus 3.79y, or plus 3.79. You can do that, and you can use it if you want to, but I'm just going to round for niceness sake. Okay, to see how this lines up with my data, so there's one more thing I want to do. Okay, last thing. Graph your new equation and see if it fits your data. Now, my R value is over a 99%, right? So it says that's going to fit. Okay, 99% fit is what that line of best fit is. So it better be, when I graph this here in a second, it better be going through a lot of my data points, 99% of them, right? So how am I going to graph this? I go to my Y equals. Graph the line. I'm going to say equation because it doesn't have to be a line. Okay, so that starts out with Y equals, and enter your equation. Now we said ours is Y equals, it's 5. Your X button is right here beside your alpha button. It's XT theta N. So because of the mode we're in, it's going to say X, 5X. And then I had plus 4. 5X plus 4. And then once I have that entered, I'm just going to graph. Hit the graph button. Again, most of my graphing features are up here on this top row. So Y equals, window, zoom, trace, all that stuff. So my graph button is right here on the top right. Graph. And look at that equation. Okay. Now we can see this dot, this scatter point, is a little bit below the line that we just put in. And this point is a little bit above, and this point is a little bit below. But it's clipping them, right? It's going close to them. And I would say that, yes, that line fits that data very nicely, okay? So the last thing you want to do is decide if your line fits your data well. And in this case, yeah. If we've done it correctly, if it really is a linear, it really is line, and we've used linear regression, then it should be good. Now, if it was a parabola and we put a line on it, then it might not fit so well. But this one we do, okay? So here's what I'm going to say. I'm going to give you another set of data points, and I'm going to give you a chance to enter them and play with them, and then you can pause the video or whatever, but I just want you to try try this process on your own. Don't necessarily stare at me. Don't let me do it. You do it yourself. But here's your data points, X's and Y's, and we're going to say -4, -1, 0, 2, and 3 for my X values. -20, -12, -8, -3, and 2 for my Y values. So see if you can do that. There's basically 4 different steps. You don't have to do the diagnostics on again, as long as you don't clear your memory. You should be all right. And like I said, if you need to, you can pause. I'm going to run through it really fast, so I don't want you to be trying to follow me for this, because it's not going to help at all if you do that, because I'm going to go fast. But pause the tape, pause the recording, and then when you come back, you'll see me doing it. Okay, here I go. So I need to enter my data points. I push Stat, I go to Edit, and I go back to List 1. I've got -4, -1, 0, 2, and 3. Check that you're entering them properly. Back to the top, -20, -12, -8, -3, and 2. There are my data points, so that's step 1 complete. My diagnostics are already on, so that's step 2. I'm good, so I'm just going to enter out or exit out of there, and I'm going to go to Stat and Calculate. And, oh, I didn't graph it yet, so let me graph. Oh, there's my data points. Again, they look kind of linear. So I think it's going to be a line. So when I went to go calculate and I didn't know if I was doing linear or not, I had to go look at my data points, right? So do that. And then Stat and Calculate. I think it is linear, so I'm going to push 4. Enter, 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 enter. And here's what I've got. Y equals AX plus B. Okay. And I've got an A equals, now it's 3.06666, but that's like not quite 3.1. So I'm going to say approximately 3. I'm going to go ahead and round. And my B is approximately negative 8.2, but again, that's really close to negative 8, so I'm going to go ahead and round just because that makes my life nicer. So y equals 3x. Now it's a plus a minus, so that's minus 8, right? So there's the equation I'm going to use. And real quickly, let's make sure we get our r's in here. My r coefficient is 0.995. So that's 99.5% of my data are going to fall on this line. And my r squared is 0.991. So that means that 99.1% of the variation that I'm going to see is in the y values is related back to the x values. So it is accounted for by this particular input. All right, so now I'm just going to graph. Y equals, I'm saying 3x minus 8. And if we've done our job correctly, what we should see when we push this graph button is that that equation of a line will go through a lot of my data points. And there it is. Again, it's not a perfect fit, and that's why this R is not a 100% or a 1, but it's pretty stinking close, right? So that's pretty good. We like it. All right, so that gives you a bit of a feel for how to do that. Hopefully you actually paused the video and did that on your own. I'm just going to throw in one more example so that you can see this. I'm not going to do it for you, but I'm going to walk you into the process. What if I said, here's your data points. Well, maybe I will do it with you. Negative 3 and 3. Negative 1, negative 11, 0, negative 9, 2 and 13, and 4 and 59. Okay, so again, 5 data points. It's not always 5 data points. I just find that 5 data points is helpful for me. So I'm going to clear out my equation real quick. And yeah, let's just go ahead and do it, because I want to show you what this looks like. So when I plot these data points, let me go into Stat and Edit. And again, my x's are going to be in L1, so negative 3, negative 1, 0, 2, and 4. Make up a bunch of points to make sure you're okay with this, and you can do this process on your own quickly. And my y values are 3 and negative 11 and negative 9 and 13 and 59. Now there's an interesting thing. Pay attention. It was positive y values and then negative and then positive again. And that should be one of the tip-offs that this probably isn't a line. Okay, so let's see. Y equals, okay, here's a problem. I only see 4 data points, and we know we have 5. And by the way, this is not a line, right? So I'm going to zoom Stat just to kind of cheat and get my window to fit it. If you're not sure, the problem here is probably this 59, right? He's way out of the window. So I'm going to zoom and then 9, and here it is. So yeah, it looks like it comes down and then it comes back up and hits that y-axis there, and then it comes on up, okay? So I'm going to take a wild guess. This is not a linear equation, okay? Not a line. Okay, but it does look kind of like a parabola, right? So I'm going to take a wild guess, and I'm going to say that this is a parabola. And what kind of an equation gives me a parabola for the graph? Hopefully I'm hearing you say this is quadratic, which means x squared, right, instead of just y equals x. So pay attention to that, okay? The rest of the process is exactly the same, except that instead of picking linear, we're going to pick quadratic. So let's see if we can sort that and find it real fast. It works the same, so I'm going to go Stat and Calculate, because I want to figure out what the test is. And as I go through, I've got 1 variable stats, 2 variable stats, linear regression, quad reg, that's probably it, right? Cubic reg, that would mean x to the 3rd. Quartic reg, that would mean x to the 4th, okay? So we're going with quad reg, number 5. Okay. Again, same stuff. Is it in L1? Is it in L2? Yes, 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 yes. I just want you to calculate. But this screen looks different. Okay. This screen says, oh, since you're doing quadratic, that equation is y equals ax squared plus bx plus c. Right? There's my parabola, quadratic formula, quadratic equation, I should say. But it's telling me a equals 3, b equals 5, equals 5, and c equals negative 9. And it's really, really, really close. Okay? Now, I've got r squared here, okay, and it says that it's a 1. Now, that means it should be pretty stinking perfect. But it doesn't give me the r, and I'm thinking it's because it's quadratic. It's just giving me a weird value. So r squared equals 1. If you wanted the r, you would just square root both sides, right? And it would still be a 1, so no big deal. Okay. So what I want you to take just a little bit of time maybe and practice this process of substituting in for the A, the B, and the C. Because it's not okay to just give me this screen to just say A equals 3, B equals 5. I'm going to say, what's the equation? So I need you to be able to substitute in and give me the actual equation. So take a second and make sure you know how to do that. Maybe do 2 or 3 problems. So y equals, we're not going to write A, we're going to write what? 3. Substitute that in. X squared plus, we're not going to write B, we're going to write 5. X plus, except that this is a plus and my C value is negative, so positive and a negative is a negative, so minus 9. There we go. Okay. So as I go to enter this equation and see if it represents my data well, think about that. It's really nice that this one had really nice pretty whole numbers, but if it didn't, you would just round to 1 or 1 decimal or 2 decimals or whatever. Okay, so y equals 3x. I need this thing squared. There's 2 ways to do it. The easiest way is this little x squared button. If you go to 7 and then up and to the left, there's that x squared button. Okay. And then it just squares your x value there. Okay, plus 5x minus 9. So there's one way to do it. The other way you can do it, so I just want to show you this, is 3x. You can raise it using the house top, the caret top, which is right above the divided by. Raise it to the second power. But be careful because a lot of times, like this calculator, I'm still up in the exponent. So it doesn't come out of the exponent until I tell it to. So I'm going to arrow to the right. Okay, now I'm not in the exponent anymore, so now I can enter plus 5x minus 9. So if you get up there in the exponent and it's not coming down on its own, just arrow over, you should be okay. Okay, either way is fine for how to graph this. So I'm going to hit graph, and here's the first one. Look at that, that's really nice, very pretty. Only using 5 data points, and here comes the second one. Mine's red, so you can see it up against the blue. All right, so they are the same equation, so of course they're on top of each other. So using only 5 data points, if they're well-placed data points, I can get a pretty good representation for a quadratic equation. If they're not very well-placed, I might need more data points, but this one, I think I chose them pretty well to help me out. All right, so that's the idea, okay, for how to do this. How to do linear regression. Remember we said in the last video that one of the reasons you might want to do this is to get a good model to fit your data, to represent all those data points you've got. And that hopefully if you have a good model, you might make predictions. Okay, so like say if you had a linear cost function and prices just keep going up and up and up and up on whatever your supplies are for your business, then maybe I can make a prediction for what's it going to be in a month, what's it going to be in 2 months, and then all that. And the way I do that is by using my data, finding a line of best fit, and then making a prediction. So we can use this in business and all kinds of stuff. It's not just a mathy stats thing. Okay? So that's it for how to use your calculator. Again, don't stress out too much about the button pushing process, but I do want you to know something about it and be able to answer intelligently about these kinds of questions on the test. All right, thanks. Take care. Let me know if you have questions.